All right. So reminder, Friday, test 1. It will open at 12 a.m. and you will have until 11:59 p.m. to start. Do not wait until 11:59 p.m. There's a possibility you might get locked out. Like the latest I would try to start it would be 11 p.m. That would be me, just to give me time to make sure there's no bugs in the ProctorU. Speaking of which, ProctorU, I put up that practice exam up on Blackboard. And it's not a practice exam for the material. It's a practice exam to make sure your computer works with ProctorU and everything's a go by Friday. So I cannot stress this enough. Try this before Friday. Do it before Thursday even. Like, make sure your system's ready to go. It'll take you maybe like 5 to 10 minutes if everything's working properly, because there's going to be nothing worse for you than trying to take your test on Friday and finding, oh, something's not working like I thought it would be. Now I'm going to freak out because it's 10:30 p.m. and I'm trying this for the first time and it's not working. Remember, I'm giving you extra credit for this, for doing like just making sure that your system can work with the test. If you come to me on Friday, like Friday night, and say, Dr. Andrews, my system's not working with ProctorU, and then I look and you never tried the practice test, I'm not going to be thrilled. I'll still help you, but we could have averted this earlier. Remember, on your Blackboard, the test 1 folder has the PowerPoints, which test 1 will cover. The practice problems in there are going to be your best friend from doing well on the test. If you can do those, you can do the test. When taking the test, make sure that you have your periodic table printed out. Make sure you have your equation sheet printed out. You can have blank pieces of paper to write on. That's no problem. And you can have your calculator out. So with all that, does anyone have any general questions about the test? And also, if you want specific like questions, like how do I solve something, I'm always available to meet. So you just have to let me know when a good time to meet is. But any general questions people might have about the test they would like me to answer now? What are the sections again? Like what's on the test? It's all under the Blackboard test 1 folder. It goes up to chapter 3 something. I can look that up. I just don't know it off the top of my head, just because I sectioned everything off into various PowerPoints. But yeah, if you go into that folder, you'll see what the last topic was that we covered. And you'll see that that's where we're ending it at. But yeah, I can definitely just open up my Excel folder or file and look at that if you want. How many questions are there? How many questions are there? I don't know, 20? I just looked at it yesterday too, but yeah, 20-ish. Maybe not that many. Few multiple choice, a lot of questions of how to do math. Are we allowed to backtrack? So the way it's going to be set up is that you'll be able to see every single question at once. So you can skip around. Yep, and you have 1 hour to do it. All right. And just as a reminder, this will not be on test 1. The stuff we go over today will be on test 2. Not on test 1. So don't worry. You can freak out about this material in about 3 weeks from now. But we got to keep moving, especially after losing a week. And so what we're going to talk about today are solutions. In general chemistry, in chemistry in general, see that joke I did there? Not on purpose. A lot of the science that we do in solutions. So we have to learn how to talk about solutions, and we have to learn how to calculate using solutions. First off, we have our terms here, dilute and concentrated. So first off, let me take back. When we talk about solution, there's generally 2 parts. We have the solvent, which is just simply the majority part, and the solute, which is the minority part. So whatever substance you have more of, we call that the solvent. Whatever substance you have less of, you have the solute. Usually the solvent is water. Once you get to organic chemistry, if you're going that route, you'll use different weird things. And then once you come back to biochemistry, if you go that route, you'll see, oh, we do everything in water. So I have an example here of salt water. Solute being salt, solvent being water. And there's 2 different terms we use in chemistry for dilute and concentrated. Dilute just means you have a little salt. Concentrated means you have a lot of salt, or a lot of solute, I should say. And there's no like cutoff to when you become dilute or concentrated. Like I can't give you a number to say, okay, once you're past this point, you're concentrated. Or if you're below this point, you're dilute. It's more of a feeling thing where once you start working with solutions, you get a feel to what people call dilute and concentrated. But in science, right, we need to be specific. And for that, we use numbers and we use the term molarity. And this is something I want you to burn into your brains because we're going to use molarity a lot. So whenever you see big M, I want you to remember this means moles divided by liters. And this is molarity. This is how we'll talk about concentration for solutions. We will always be talking about molarity of solutions. And it's the amount of solutes in moles divided by volume of solution in liters, right? Always moles divided by liters, and we always talk about it as big M. So we're going to work on calculating some molarities here. And I will do A and B for us, and then I will let you try to do C and D, right? So question 1A, what is the molarity of 32 grams of carbon dioxide in 1.25 liters of solution? All right, so we need to go moles to liters. So hopefully you know how to do this now because you will be tested on this on Friday, but we are grams and we need to go to the moles. And the way we do that is molecular weight. And so for carbon dioxide, we take out our periodic table. We look up carbon. Carbon is 12 plus 2 oxygens. Oxygen is 16. And we got 2 of them times 2. And so the molecular weight of carbon dioxide then is 44.011 grams per mole. Once we have that, we can convert to moles. So I have 32 grams of carbon dioxide. Using my train tracks, my molecular weight, I have 44.011 grams for 1 mole. Grams cancel out. In train tracks, I do 32 times 1 divided by 44. Again, I hope we have this skill down because it's going to be on your test on Friday. And we find we have 0.727 moles of carbon dioxide. Right. So now I need to do molarity, which is moles divided by liters. So I have 0.727 moles divided by 1.25 liters. So the molarity of my solution is 0.582 molar. 3 sig figs, because I'm doing division. This has 3 sig figs. This has 3 sig figs. So that makes my division easy because my answer should have 3 sig figs. Don't forget about your sig figs for Friday, right? Remember, multiplication and division, your answer goes with whatever has the smallest number of sig figs. For addition and subtraction, you got to look at the decimal places, right? And you pick the number with the smaller amount of decimal places. And just a tip for the few of you who came here today and hopefully watching on YouTube before test 1 on Friday, there is a question during the test where I just asked you, okay, here's a problem. What's the answer in sig figs? And so I give you the answer, but I give it to you like with 5 or 6 different ways with different sig figs in it. And your job is to say, okay, this answer has the correct number of sig figs. So make sure you have to, how to do that. And if you don't, make sure you review. So that's the question for 1A. Rather simple, right? Moles divided by liters. B, what's the molarity of 1.23 moles divided by, or in 1.23 milliliters? Well, here we don't have to go from grams to moles because we're already in moles. What we have to do is go from milliliters to liters. Again, this is something else that will be on test 1. I have, I don't know how many questions, but at least one, I think I have 2 questions where it's nothing but can you convert between the metric units for me? So make sure you review that for test 1. Make sure you know how to go from one metric unit to another because there's at least 2 questions on test 1. That's all it asks. All right, so milli to liter. So there are 1,000 milliliters to liters. And a common problem I see for students when doing this is that they forget which one to multiply and which one to divide. So you can do train tracks for that because train tracks are the best ever. Just make sure you match up your units. Milliliters cancel out. So it's 123 times 1 divided by 1,000, which is 0.123 liters. Right, molarity, 1.23 moles divided by 0.123 liters. This is 10 molar. Right, so now that you've seen how that is done, if you have questions about what I did for A, B, or C or D, let me know. Otherwise, I'm going to give you a few minutes here to try and do C and D. And I'm going to pop up my little question timer poll. So let me know how you do with C and D. If you have questions, let me know that too. Otherwise, I will be back to give you the answers. All right, seems like we have a number of us finishing. A lot of us got them. Some maybe not quite sure. So if you're still working, feel free to continue to work. But I'm going to end this poll and just go over briefly, as there didn't seem mass confusion at least. So here C is basically the same thing. Well, actually, C is a little bit different. C, I'm asking how many moles are in the solution. I'm not asking for molarity because I already gave you molarity, right? And so remember, molarity is moles divided by liters. So 1.23 big M means 1.23 moles divided by 1 liter. Then we have to do a similar conversion that we did in B here to convert from milliliters to liters. So the conversion's up in B, so I won't redo the train tracks, but it's 0.230 liters. So here I'm going from molarity to moles, so I need to multiply by liters, right? Because I'm canceling out liters. And here, 1.23 times 0.230 is 0.283 moles. Then D, I have 3 moles of NaCl. How many liters must I dissolve to have a solution that's 0.859 molar? So here's a little bit algebra problem for us, right? So 0.859 moles divided by 1 liter, because remember, that's what molarity is, equals 3 moles divided by X liters, right? So mathematically, I'm trying to figure out, okay, what is my volume that I'm trying to dissolve my 3 moles by? That's my X, to have it equal this 0.859. So I multiply each side by X, right? And I get 3 equals 0.859X. Then divide each side by 0.859. And you should get X equals 3.49 liters. So that's how many liters I need to dissolve 3 moles of NaCl by. Any questions about our molarity calculations here? Well, if you do have a question and you're still typing, feel free to continue to type. Otherwise, I will start to move on here. Right. So we looked at basic molarity. Now we're going to look at how to dilute solutions. And we use the solution dilution equation, which is M1 times V1 equals M2 times V2. Molarity of solution 1 multiplied by volume of solution 1 equals molarity of solution 2 multiplied by volume of solution 2. So solution dilution equation is great, but be careful. In the past, what I've seen is that students love this equation since it's relatively simple, and they love it so much they use it on stuff that is not relevant to solutions and dilutions. So remember the rhyme, solution dilution. Only use this equation when it comes to solution dilution. If you are not diluting a solution, then don't use that equation. If you are diluting a solution, feel free to use this equation. M1V1 equals M2V2. And let's do A together. then I will let you take a stab at this. The hardest part about M1V1 equals M2V2 is assigning variables, right? Because a lot of the times you're going to get this in a word problem like I show here, and you just have to assign variables, right? So let's read 2A together. I have a 1.2 molar solution of NaCl. All right, I have a molarity of a solution. So I'm going to say this solution of NaCl they're talking about, I'm going to say that's solution 1. When you're doing M1V1 equals M2V2, it does not matter what you call solution 1 or solution 2. All that matters is you are consistent, right? So I have a molarity of solution 1. So this is my M1. I take 30 mils of this. Okay, I'm taking 30 mils of that. So that's my volume of the solution, 30 mils, and I mix it with 70 mils of water. What is the molarity of my new solution? All right, I'm talking about a different solution, new solution. So this is solution 2. What is molarity? So that's molarity 2. Now I'm trying to figure that out. That's my unknown. So if I go back to my solution dilution equation, I have an M1, I have a V1. I'm trying to figure out M2. So let's figure out what V2 is. Right. So we have to go back to this word problem. And a lot of the times I like to draw pictures. So solution 1, right? I take, this is 1.2 molar. I take 30 mils of this and I add it to solution 2, which originally had 70 mils. Therefore, my volume of solution 2 is 30 plus 70, which is 100. All right. So I know it will be tempting to just see the number 70 and write, oh, that's volume 2. But what you really need to do in word problems in general, and when reading in general, slow down, read it more than once, draw out pictures if it helps, digest that information, ask it, what is it asking me? What is it telling me? And then work your way from there. So there's my setup. I have one equation, one unknown. Let's fill in M1V1 equals M2V2 now. So M1, 1.20, V1, that's 30. All right. So another question I get is, does the volume have to be in liters? No. The volume has to have the same unit between V1 and V2. That's all that matters. It can be milliliters, it can be liters, as long as it's the same value, unit rather. Same with here for my M1 and M2. These have to be the same unit. Right, so M1, V1 equals M2, unknown, multiplied by V2, which is 100 milliliters. So to solve this, simply multiply 1.2 by 30, divide by 100, and your M2 equals 0.36 molar. Right. So there's M1V1 equals M2V2. So I want you to take a stab at 2B and 2C now. If you have questions, of course, how I did 2A or anything, let me know. I'm going to pop back up that progress poll to get a feel. But yeah, see if you can get the handle of M1V1 equals M2V2 here. All right, so question, why did I put the 100 instead of the 70? It's because what the problem was saying to me. The problem said, right, I took 30 mils of my original solution and mixed it with 70 mils, right? So that's my solution 2. I'm taking solution 1, adding it to water. So for solution 2, my new volume is 30 plus 70, right? If I just did 70 from the word problem itself, that's only water, right? So the molarity, the molarity of salt in water is basically 0. So what I'm doing is I'm diluting this 30 mils into 70 for a total of 100. So basically, if I was going to read out this equation in English, is I take 30 mils of a 1.2 molar solution and I dilute it to 100 mils. What's my new molarity? So that's why we picked 100 over 70. Does that make sense? Or are you still a little confused? Okay. All right. Looks like we do have some people finishing up here. I will say, if you do like the no idea, feel free to like send me a chat like what you're thinking or like your thought process, and I can definitely chat back to you to try and move us forward there. So I'm just going to end that because looks like we have the majority of people here finishing up. So let's look at B. I have a 1.20 molar of NaCl. Here's a solution, so that's M1, sure. I want to make a solution. So I want to make, so new solution, right? I want to make a solution that is 500 milliliters So this is a new solution. So this has to be solution 2, so V2. That is a molarity of 0.75. Okay, so this is talking about the new solution still. So this is 2, right? How much of my NaCl solution, so this is talking about this solution. So we call this solution 1. So how much of this, so that's a volume question, how much, V1, should I use for this? Again, like I said, the hardest part of this is just reading through these types of short answers and figuring out M1, V1, M2, V2, just the variables. Once you have the variables, the math is, super easy. So let's fill this in. 1.20 molar, that's M1. V1, I don't know. M2, 0.75. V2, well, I want it to be 500. So how much should I make? So that is 0.75 times 500 divided by 1.20. My volume for this is 312.5 milliliters. And if we look at sig figs, the 0.75 has 2 sig figs, 3 sig figs, 3 sig figs. It's ambiguous. I should have put a decimal there. So my answer should have 2 sig figs. So that's 3.1 times 10 to the 2 milliliters. Remember, when I move to the left, you add a positive number to the times 10 to the power of. So I moved to the left 2 places. That's times 10 to the power of 2. So you said people use the dilution equation for the wrong question. How would I know from the question that I need to use to dilute something? So I think that's part of that is why I think drawing pictures is good. Because if you draw a picture of this, right, I have 1.2 molar, and I want to take a certain amount of it to a new solution. So whenever you're like mixing solutions and you want to find out a molarity or a volume, that's dilution equation. Another hint is that you're always going to be solving for a volume or a molarity. So that's another hint that you have to be solving for a volume or molarity. And the problem will be talking about 2 solutions. So the things you're looking for is, are we talking about 2 different solutions? Are we talking about mixing one solution with another or diluting a solution? And am I being asked to solve for a volume or molarity at the end? That's how we know we're going with the dilution equation. And like on the test, it's going to be something like I gave you for question 2 here. Like I would probably ask it the almost the same exact way. So would you want the answer? What I want the answer is 312.5 or 3.1. It should be 3.1 because we're doing multiplication and division here. And so we have to follow the multiplication and division sig fig rules. And 0.75 only has 2 sig figs. So the more correct answer would be 3.1 times 10 to the 2. 312.5 isn't wrong, but it's not worth like 100% of the points. It might only be worth like 95% or 90% of the points. Like I said, that will be something that's explicitly tested on test 1 and something I'll look for on tests moving forward is your mastery of the sig fig rules. All right, our next one, I have 2 molar HCl solution. Okay, I'm talking about a solution, molarity. This is the first solution I'm talking about, so that's M1. I want a different solution. So that's solution 2. I want it to be this molarity, so M2. I want the volume to be 250. So this is talking about my second solution, so that's my second volume. How much HCl, okay, so I'm talking about my original solution here, should I ask? I know I'm going through that a little fast, and for you all who haven't worked on these type of problems for the last 5 years, of course you're not going to be able to see it this fast. So that's why I said, read these a couple times, draw your pictures. The best thing you can do is start assigning variables and see what variable you don't end up with. Make sure you are assigning your 1 and 2s to the same solutions, right? Right. So I'm trying to solve V1. How much should I add? So M1 V1 equals M2 V2. M1 is 2. V1, I don't know. M2 is 0.250 and V2 is 255. So I am solving for V1 here. Get my answer key back up. And it should be 31.9 milliliters of solution. 0.250 multiplied by 255. Take that divided by 2. And that is the answer I got. All right. Questions about our sig fig, or not sig fig, solution dilution equation, or just call it the dilution equation. For every answer we get, do you want us to round, or if we don't, you will take off for that? Any single math problem you do, I want you to be counting sig figs. Like I said, for test 1, I'm going to have explicit questions on test 1, where the question is simply, what's the answer with the correct number of sig figs? Moving forward, like on test 2, 3, 4 in the final exam, I won't be asking questions like that specifically. Well, I will on the final exam because it's cumulative. But on tests 2, 3, and 4, you will have math problems, right? And I will be looking for sig figs. So it's very important that we learn it. Like for test 1, we have those skills down, and that we keep applying those skills to test 2, 3, and 4. Because a lot of the times for my answer key, I will always give a certain amount of like points for, did you have the right sig figs when you did this calculation? I mean, they're not a large amount of points. The calculation itself is more important, but the sig figs shouldn't be ignored. All right. Not 31.9. Should be 31.9, right? Because there was 3 sig figs here, 3 sig figs here, 3 sig figs here. So your answer should have 3 sig figs, which is why it's 31.9. I'm not quite sure why you're saying it's not 31.9 then. right, so I'm gonna move on to the next question. If you're still typing something out, feel free to continue. I'll answer it once I see it in chat. The last thing, we're not going to finish it today, but I want to introduce it, is solution stoichiometry. Stoichiometry, we talked about, and it's basically, when we have a chemical equation, how do we use the numbers in front of that equation to tell us how many moles of products and reactants will be created, or how many will react? And so when we're doing solution stoichiometry, we can determine volumes and moles using molarity here. So when I did the calculation, I got 31.875, and I took the 3 figs, which would be 31.8. Oh yeah, you always round when you take sig figs. Yeah, so 31.875 is 3 sig figs, right? So I see what you mean now. So the answer is 3 sig figs. So I round here because this is a 7, so you round up to 31.9. One of the joys of teaching online and making sure we don't have just random sounds. I will reiterate, if you find it easier to say something, always feel free to tell me, and I can always unmute you too. Or if you don't want to have your voice recorded in eternity, chat's just fine for me as well. All right, so I'm going to do 3A here, solution stoichiometry. And we probably won't have time for you to do 3B. We might pick that up on Monday then, or no, I will tell you how we're going to handle that. But let's look at 3A for solution stoichiometry. So we have a balanced equation already. We have 3 moles of sodium hydroxide plus phosphoric acid goes to 3 moles of water plus a phosphate group plus 3 moles of sodium. The question is, if I have 250 milliliters of 2.0 moles of NaOH, how much H3PO4 must I use for it to react? If my H3PO4 has a molarity of 1.25. Okay, there's a lot of moving parts to that question, and it's very easy to feel overwhelmed. One of the first things I like to do when looking at a question like this is just figuring out what should my final unit be, right? So that's where I'm looking for like my question words. How much? Okay, so this is asking me for a volume, right? That's like how much, that's volume. How much H3PO4? So when I finish this whole question, my answer should be some volume unit of H3PO4. Units are very important. Units will tell you if you have your problem solved correctly or not. So one of the first things I like to do is just ask myself, what unit is my final answer? That's volume of H3PO4. Okay, so I have 250 milliliters of 2 molar NaOH. That's my starting conditions. And I also have an unlimited amount of 1.25 molar H3PO4. So I need to convert my starting condition, NaOH, to H3PO4. And the only way I can convert between one unit and another is by being in moles. It's the only way to do that. To go from NaOH to H3PO4, I have to be in moles of NaOH. So right now I have a molarity of NaOH, and I have a volume of NaOH. But we already learned today that I can use these two pieces of information to figure out in this chemical reaction, how many moles of NaOH do I have? So that's the first thing I have to answer. how many moles? I can't write today. How many moles of NaOH do I start with? So if I have 2.0 moles per liters of NaOH, and I have 0.250 liters of NaOH, that's coming from my 250 milliliters there. I do 2 times 0.250, which should be what, 0.5? Yep. So in this reaction, I have 0.50 moles of NaOH. All right, before I go on, I just want to stop right there and ask, okay, did I lose anybody? Are you not sure what I just did there? Are you not sure why I did that? Let me know. Okay, so I did lose people there, which I figured. Okay, so the question is, right, I have a certain amount of sodium hydroxide, NaOH. I have 250 milliliters of this NaOH, right? So let's draw out this picture. I have 250 milliliters of NaOH, and it's at 2 molar. And I want to know if I combine it with H3PO4, which has a molarity of 1.25 molar, what volume do I need to react with this completely, react with my NaOH completely, right? So I have these starting conditions of NaOH, but my final answer wants to be in H3PO4. So I need to convert between NaOH and go to units that are now H3PO4. So I have to convert from one molecule to another. And the only way to convert between one molecule and another is if you are working in the unit of moles. So to be able to convert between NaOH to H3PO4, which my answer wants to be in, I have to know how many moles of NaOH are in this solution. That's what I'm trying to figure out right now. And I'm given a molarity, and I'm also given a volume of NaOH. And question 1 today, like 1C or 1D, I forget, but we looked at today, if you have a molarity and if you have a volume, you can determine how many moles of NaOH you have, or how many moles of that solution, because you just multiply the two, and the liters will cancel out. And you're left with 0.50 moles of NaOH in this solution, right? So I know how many moles of NaOH are in my solution, and I'm in a unit of moles, so now I can convert to H3PO4. That help a little, or still like you are just speaking gibberish? Are you still speaking English? And I know it's confusing. Okay, helped a little. Okay, so as long as you can follow how I figured out the moles of NaOH, that's good. If you understand, like I multiplied those two things to get moles of NaOH, we're good for right now. Okay, so I have 0.5 moles of NaOH. And the question is, if I combine this with 1.25 molar H3PO4, what volume do I need to have this react completely? That's where these coefficients come in. So I need to convert between NaOH and H3PO4. My conversion factor, which we talked about on Monday, I believe, are these stoichiometry coefficients. So this equation says for every 3 moles of NaOH, I need 1 mole of H3PO4, right? So I start with 0.50 moles of NaOH. For every 3 moles of NaOH, that reacts with 1 mole of H3PO4. So we did that on Monday, right? But we weren't working in solutions. The only difference now is that we're working with volumes and molarities. So my second question is, so question 1 was that. Question 2, if I have 0.50 moles of NaOH, how many moles of H3PO4 do I need to react completely? That's what this equation is. So you do 0.5 divided by 3, which is, in this chemical reaction, you need 0.17, or actually 0.166 repeating moles of H3PO4 to react with 0.5 moles of NaOH. And I figured that out through stoichiometry. All right, we are running out of time, so I'm gonna kind of like go through this a little bit fast here, and then we'll pick it up on Monday. So question 1 is done. Question 2 is done. Question 3. What volume of 1.25 molar H3PO4 contains 0.166 moles? So I just figured out, okay, to react with this amount of NaOH, I need 1.66 moles of H3PO4. If my solution, I already have it drawn here. If my solution is 1.25 molar, what volume contains my 1.66 moles, right? So this is another thing molarity will tell you. So if I need 1.66 moles, this is just another conversion. I have a solution that is 1.25 moles per 1 liter. So you see, if I do this calculation, this is all H3PO4. Moles cancel out. I'm left with liters when I do this calculation. Always remember, this is moles divided by liters, big M. And when doing math problems like this, always write down your units. Make sure they are canceling correctly. Units are the easiest way to do math because the units will tell you if you need to multiply or divide something. So we're taking our 0.166, dividing it by 1.25. I need 0.13 liters. So the answer to the question, I need 0.13 liters of this 1.25 molarity solution of H3PO4 to react with this much NaOH. All right, so these type of questions, the solution stoichiometry question, when it comes to test 2, this will probably be the question that gives people trouble the most. You can see it is, although it's a very short question, it's very complex. Luckily, you don't have to worry about that for Friday. But what we'll do is we'll revisit this on Monday, because I'm sure you're going to forget about this, because I know after a test, people usually go through the brain dump where they cram, do the test, and then they blank out for the next couple of days. So we'll revisit this on Monday. I will be sure to have a lot of practice problems available online for you for this. So don't worry if you didn't get it quite now. This is online. Be sure to revisit this lecture, how I solved this question, and we'll go through 3B. Friday, remember, test one. Please do the practice ProctorU does my system work test. I cannot stress that enough. Are there any last minute questions people have before I sign off? And if you want to talk to me one-on-one, feel free to send me an email. We can set something up. But while you have me, any last minute questions people might have about anything? All right, I'm not seeing anything come up. If you are typing, I'm going to talk a little bit slow to give you time. But otherwise, good luck. Study hard. If you have any issues getting the test started, the practice test started, please don't hesitate to reach out to me. Have confidence in yourself. Breathe, sleep, eat, exercise, do all that stuff. It's all part of having a functioning and strong brain. Otherwise, I hopefully will see you Monday, and hopefully you'll do well. You won't be devastated to see me. You won't be cursing my name on Saturday. I'm sure I have enough curses already through my short career of teaching. I don't need any more. All right, all kidding aside, take care, everybody, and I will see you after the test. Have a good one.